Hello and welcome to the MLOps Minute. So that's it. At last we can set up the first stage of our training pipeline, the extraction part, and in this episode I'm going to focus a little on the working method for setting all this up. So here we go. If we take a look at the big picture here, we're going to focus on this module, the very first one, extraction. We're going to receive a set of flat PDF files as input, and we're going to extract all the flat images from these PDFs as output. So if I take the solution as we'd expected, at the end here we'll have a train directory containing all the steps in the training pipeline, and then we'll find 4 subdirectories. Here, for example, extraction, label, split data. The idea is that each step here will be completely decoupled from all the other steps. Because when I say decoupled, I mean separate, meaning that there will be no links even in the library dependencies. And why? Because in computer science, if we cut the code, we create links and a spaghetti bag of knots, making our project unmaintainable. Decoupling our project will allow us to work independently on these modules without the risk of breaking the rest of the project's code. Now, if I go back to the project we'd started to set up in Git, so we'd set up a CI/CD, and then I created a train directory, and inside it an extraction directory, and in it I've already put some functional code, but it's not finished yet. Here you can see an important project, pyproject.toml. Why? Because I used Poetry and not PipEnv, because this will enable you to do a first exercise. Now that you've mastered Python, you've mastered environment variables, how to switch between versions of Python, you'll be able to stand on your own 2 feet. Go to the Poetry site, install Poetry, and start using it. So here we have a file that is declared with certain dependencies, and we are going to use Python version 3.10. Similarly, if we had started with Python version 3.11, we will have to switch back to Python version 3.10. What you need to know is that Poetry, like PipEnv, to take an exact picture of the libraries and all their dependencies at a given time. What happens is that if I don't have a Poetry lock file here and I do a Poetry install for the first time, it'll take this picture, download all the packages, and take a photo of all these versions and generate the poetry.log file. As a result, if Poetry installs again sometime later and that log file is present, Poetry won't use the .toml file but rather the .log file, and it will take the exact photo of these libraries. And this is extremely important. Here you can see some Poetry related features that allow you to have the same notation as Python dependencies, but it adds the ability to use little tilde or little hats as with npm with Node.js. With the little tilde, in other words, if there is no .log file and you do an initial Poetry install, well, the little tilde is that it will always take the patch number that's the highest major minor patch number it can find at that moment, which will then be versioned forever in the .log, and the little hat is major minor, so it'll take the highest minor version it can find at that moment when it generates the lock. But afterwards, if the lock is there and Poetry install is redone, then it'll take that version and it won't move again. For direct dependencies such as PyMobDF, we try not to put a hat, it's much simpler. Here, I've put a little tilde for the Python version, because today Python exists in version 3.10.14. There have been security patches, but the only installable version available on Windows is Python 3.10.11. So in production and training, we'll use the latest version patched with security fixes, but on my machine, unfortunately I can't on my Windows machine. So here's a little about the project setup. What happens here is that I have a project completely isolated from the rest of my project. To work, I'm going to open another PyCharm where I'll really isolate myself on this directory. And in PyCharm, what I'm going to do is configure poetry so that it's taken into account as a default interpreter. So I go to File Settings. Here I go to Project Python Interpreter. Add Local Interpreter. And when my screen appears, it's a little long. You can select Poetry Environment. My IDE is a bit slow, so I'll select Python 3.10 and the Poetry executable. And now I can work. What happens is that I already have a data set in place, which is available at this address. I made a git clone. And instead of doing it just once, I versioned it in a file called initdataset.sh. Why? Because eventually I'm going to want to automate all these actions. And so the manual action I took, I put in a .sh file. This enabled me to download my dataset to my workstation. In a company, you probably won't be able to do this all the time on your workstation. You'd probably have to be on other environments. But now I'm going to find my set of PDFs with my dogs. I'm not even going to open them here. They all have a unique ID name. What happens is that for this use case, I haven't even opened any environments other than my IDE. It's a dream boulevard for TDD. In other words, I know what I have as input and I know exactly what I want as output. So I've started a test which for the moment isn't unitary. It's not finished yet. I created a directory where I put 2 PDFs. Then I created a test and iterated very quickly to set up my code. The good thing is that you come in and you don't know the code. It's very simple. You can get there. Debug with Python. Let's take a look at the code. Remember, this is not a unit test. I'm going to do F11. I enter my method by typing f11. Then fonts. I arrive in my extract image method. There I can see what the algorithm is. I'll browse my input directory to list all PDFs. I'll retrieve my 2 PDFs. Then I have a small piece of code. If my output directory doesn't exist, so output, it will be created. Next, there's a reference to calculate the number of output images. Let's browse our PDFs. Open this. Now what we're going to do is, apparently, we won't go into it, but we have a little algorithm that wants to use PyMopDF to extract the images from my PDF and return the list of images from this PDF. Next, we can format the names of the output images. We'll keep the PDF name, the page index, and the image index within the page. We generate a file name. We'll take a look at what it looks like. A file name is generated. We'll save our output image. What happens is that our test, which is not unitary, I'm going to finish the test. I can't remember which shortcut, but I think it's 5. I let the test run. It's green. It's a non-unitary test. Why? Because it created my images and output on the hard disk. That's not what we want. This means that my code isn't very clean. On the output side, I put assertions that count the number of images, whereas I have a very well-defined pattern for my output by saying it's the file name. I'd really have to test this output pattern to be sure that my input really corresponds to what I'm expecting as output. But it doesn't matter. I've iterated extremely quickly. What happens now? I'll be able to set up a CI/CD. I'll be able to modify my GitHub action. Let's take a look at the big picture. I've created a CI/CD here. Forget the pilot for now. We've set up several stages here. In other words, this pipeline will be launched if we push directly on the main branch or if we make a pull request to the main branch. Behind this, we create an environment variable to our version of Python, and then we'll launch a job that will allow us to replay our unit test of my extraction module. That's great. What's next? We're going to make a Git clone of my entire project. By doing a depth zero fetch, i.e. we don't take the whole history, we just take the latest version. It'll go faster that way. Next, we'll install Python. We install Python. We'll install Poetry. That way, Poetry will be available. And now we're going to use Poetry, which we'll describe a little more in the next few episodes. We'll put ourselves in the train extraction directory. We'll really isolate ourselves in this directory. And we're going to do Poetry install. The log file will be versioned in Git. We'll take the exact picture of the same dependencies I had at that moment, the moment I did it on my machine. Next, here's a command to launch submodules. We run Poetry run coverage, which in turn can launch submodules. Run -m, then the unit tests. I invite you to review the previous videos on unit testing to understand this command. Next, Poetry run to launch code coverage, which means that behind, I did a git add to add my files to the project, but be careful. If you do a git add, be careful not to kill your git history, because right now I've downloaded a dataset here that's almost a gig of data. And in fact, you need to set up a git ignore file here, which allowed me to exclude this directory and avoid doing anything stupid and veroding my git history by uploading a gig of data. Likewise, I've excluded PyCharm's local working directories, the idea. So I added them to the git ignore. And again, for the moment, my test is not unitary, even though it's not very clean. And I've excluded this output directory so that it doesn't get pushed into the Git. So what happened was I created a branch. I did git checkout-b feature train extraction. I did a commit push. And then I went to GitHub to make a pull request here, which I've called feature train extraction add extraction. And that launched my CI/CD. So here I have my failed pilot. And I can see the details of my unit test execution. So we've installed Python, we've installed Poetry, and now we've done it. Downloaded my project. I've got the exact picture of my project on my computer and ran unit tests on this module. So if these unit tests are green, well, I'm pretty confident. Now, what's happening is that in my pull request, like how can I say, so here I've got this CI/CD that passes but not the pilot. And my test is not unitary. So I trust my colleagues to reject my code and ask me to make sure that my code is clean and that the test is really unitary. So don't do any disk writing and let my little module here be completely independent of how the disk is read and written. And now it's up to you. You can make this code completely unitary if you like. What I'm going to do is in the comments of the video or in the text of the video, I'm going to put the link to this branch and you can drill down if you like and try to play with it, set up the project and make the test completely unitary. Thank you very much. See you soon for more videos.